All right, well, good morning, welcome. This is Elixir as your development culture. So who is this guy on stage? Well, I am Henry Popp. I am one of the co-founders of Codedge. Codedge itself, we are a software design and development consultancy. We've worked with companies of all sizes, everything from tiny startups all the way to Fortune 100, such as Redacted and Non-Disclosure Agreement. Those are my favorite kind. Yeah, unfortunately, we can't talk about a lot of the work that we do, but kind of the gist of us, think SEAL Team 6. So we get in there, we fix Elixir systems, we build Elixir systems, and we're very, very good at what we do. But it didn't always used to be that way. Today is a talk of heartbreak, of triumph, and hopefully a bunch of code snippets that don't bore you to death. We'll see. So let's get started. So the year was 2015. My co-founder and I were fresh out of college. We had been doing a lot of Ruby on Rails work and native mobile development in college for various clients, but we decided right after graduation, hey, let's actually found a company. So you can see the photo on the right. We didn't have a garage, but we did have an upstairs room in my parents' house. So that was officially Codedge headquarters for the first couple years. Worked really well for us. But what's interesting about the Codedge journey, unlike a lot of companies that adopt Elixir, we didn't have any preconceived ideas about architecture and design. We'd been building Ruby on Rails apps, but we were effectively a blank slate because we had just graduated college. And so I remember thinking around the time, I'd been studying Elixir Phoenix, kind of watching it for about a year, and I kept hearing this thing over and over again. It's like Ruby on Rails, but fast. Even today, that's how I explain it to people when they don't know what Elixir is. But I really, really wanted to try it out on a project. And so fortunately, we got the opportunity pretty quickly, right after we founded. So there was this customer who came to us, and they needed this prototype built. It was a simple CRUD application with a real-time chat prototype piece to it, which I was thinking, okay, so you've seen so many different like Phoenix demos, build a live chat in 40 lines. Yeah, Phoenix channel seems like a perfect fit for this use case. And so we built, it was the CRUD portion we did in Rails, obviously channels for the chat part, and the thing worked really, really well. So mission accomplished. We had another project very soon after that, which before Codedge, I didn't really know anything about the cattle industry. Now I know a lot about the cattle industry. So we built basically eBay for cattle. So it was a cattle auction platform that basically, and this happens across the country every day, thousands of different cattle auctions. So we figured, okay, Phoenix would be a good fit for this as well. Let's do it. So we did it. It worked really, really well. The code base was amazing, complete joy to work with, which is what I would have said if it wasn't a hot dumpster fire. So our first full-scale Phoenix application was really, really bad. But to its credit, it worked. It met all of the customer requirements. It did everything really, really responsively, really quickly. And I think this is a real testament to Elixir, that you can design a very bad code base, but it still smokes everything else out of the water. Our biggest competitors at the time were some PHP applications and .NET. We were the future of the cattle industry using Phoenix, go figure. But that said, yes, the code base did have a lot of problems with it. Had a very limiting database schema, and this wasn't necessarily Phoenix or Ecto's fault by any means. It was just more of the one database schema to rule them all. We had to generate a lot of reports. It became very difficult with a lot of the table joins and everything. Also on top of that, so we adopted the pattern that's common in Ruby on Rails, fat models and skinny controllers. That was a terrible idea. So we basically ended up with these junk drawer modules for all of our ecto schemas. It was really bad. On the front end, it was just a torrent of jQuery. Many of you are pretty familiar with this. This was our unfortunate reality before LiveView. But back in 2015 to 2016, yeah, it was bad. So I kept thinking, there has to be a better way. So who remembers this blog post? So the great Jose wrote Elixir in Times of Microservices. And this was effectively the holy grail of how to design good Elixir applications back around this time. So I was reading it, learned about umbrella apps. A lot of it led me to further read up on domain-driven design. Suddenly this whole universe opened up, and I'm thinking, okay, we have all these cool ideas, let's apply them on our next project and we'll succeed. Well, no, the cows are still on fire. So our cattle client came back to us and they said, hey, we want another platform built for some different types of cattle auctions. So this one had a bigger scope before. I didn't know there were multiple types of cattle auctions. Evidently they have their own rules. So it was a bigger scope than before, did a lot more things. So we figured, okay, we'll do it as an umbrella application. We'll do it as our first attempt at domain-driven design. And it was a way better design, mostly, kind of. It ended up being a configuration and dependency nightmare, which you've run into this with umbrella apps before. We made the classic mistake of we had an app called Repo, and that was like the whole database. You never do that. Basically, we had kind of built, it was still a truly mono repo project, but we were pretending like these are separate applications in here. It was just bad, but to its credit again, the platform worked really well for the customer, so mission accomplished there. Several projects later. So let's talk about Docker for a second. Who here remembers when Docker used to cause random kernel panics on Debian? Yeah, the Codedge remembers. So we had been watching Docker for a very long time, but we still didn't quite trust it yet. It was around the 2017 to 2018 time period, especially when they fixed the kernel panics, that we finally decided, hey, okay, yeah, let's go ahead and start using Docker. So we had a new customer come to us. The project was a customer outreach and email marketing tool. So you know how you get spam in your inbox? Well, the great thing about Elixir is it allows you to send a lot of spam really quickly. So with this project, we decided we were going to adopt Docker, but we had a very unique opportunity here. We realized that, hey, instead of doing an umbrella application, let's go ahead and split them into separate repositories entirely, because Docker makes it very easy to deploy applications. So let's go ahead and we'll break it up, all of our business domains. There'll be separate repositories, and then we'll have all the domain events propagated with RabbitMQ in a typical domain-driven style, and then we do a front-end single page in Vue. And guess what? It worked. It worked really well. This was the best architected application we had done to date. So we figured, okay, let's do it again. This next project, 6DOS, is known as 6 Degrees of Separation. So this is a really, really cool web app that it's kind of like a contact manager / networking tool. So you upload your contacts, and it will basically deduplicate them and score how well you know somebody. So let's say, like my co-founder in the audience, I have his home address, got his email, got his phone number, got a lot of different little pieces about him. I know him well. And this is important because with these scores that you generate, you then join teams of people, other networking type people, that let's say they want an introduction to someone and they realize, oh, hey, that person knows that guy really well. You can have an introduction made. That's always the best way to network. And so 6DOS is a platform that allows you to do that. So with the architecture on this, we did the exact same strategy. We broke all the domain events into their own repositories. But this time we're going to try something on top of it. We threw the command pattern into the mix, and this worked even better. And so before I get into the command pattern, I do want to talk about 6DOS architecture just in general. I can legally talk about this, unlike the other project, which is a big part of why I brought it up. So you'll see here you have 5 verticals. On the left side, you have the account manager. That's like user accounts and team management. You have the contact importer, which does what it says. It imports contacts. You have the contact manager, which is really where the heart of 6DOS lives. It does all the scoring, all the deduplication. It is truly a contact manager. Product manager is just your billing system. Not a lot to talk about there. And the report engine just generates some reports and sends emails out. So let's talk about the command pattern. A lot of you may know this from object-oriented. It's basically the idea that you build an object out of a command, just a general user flow or some sort of like complicated sequence of actions that you want to encapsulate in one place. So in Elixir, we do it with modules and structs, and this worked extremely well. We were designing modules that did one specific user flow, so it had all the pipeline steps in it. It had all the data that you needed. Let's take importing your Google contacts as an example. So you have to authorize with Google, you have to fetch the data, you got to sanitize it, and then you got to prepare it to go into the contact manager. Well, all of this lives in one file within the contact importer service. And this makes it very, very easy when there's errors, let's say with the Google contacts, you know exactly what file to go look at. And we like this pattern so much that we actually made an open source library out of it. It's called CommandX. So it is the coolest tiny repo that you probably don't know about. So now you know about it and go look it up. And there is another thing too. So this is really cool. We discovered when we started to put things in this style, anytime you generated documentation, your module names then became a list of everything that your service did, which works really cool for service-oriented and triple D, because then when you look at the repository, you just know that, hey, yeah, this is straightforward. So why do these things work? Well, I'm the type of person that quotes himself in his own presentation. It took a long time to put words to these ideas, but I call it instantaneous complexity. And so it's the idea that software should not be too complex at any given scope. This is actually something that you already instinctively know. It's times when you pull up a module and you're all like, oh God, that's terrible. You know, because the complexity just spills out of the screen and it gives you a bad reaction. But complexity at any given scope, well, what are the scopes? So we got 4 circles here. I consider software to be very fractal in nature. So really these are all kind of the same thing, just at different levels. Your functions are obvious, they do one thing. Your modules are a bag of functions, your repository is a bag of modules, and your system is a bag of repositories. Now, an important takeaway from this, the repository does not necessarily have to be code that you wrote. In any typical system, I might consider your databases to be repositories. Obviously, hopefully you didn't write your own database. But let's say you deployed Postgres. Well, that was a repository that somebody else wrote. You're just happening to use it on your cluster. And so when we look at service-oriented architecture and the idea of breaking up umbrellas into separate repositories, well, what we've done is made the repositories less complex, but we've made the overall system more complex. You might have seen this before in microservices, which took it way too far. I don't understand why in the software industry that it seems like when we have a good idea, we then take it so far that it becomes a bad idea. If you have hundreds and hundreds of repositories deployed on your cluster, yeah, you've done something wrong. Really, what we've done here is taken a happy medium between the monorepo style and microservices as we all know them, and really just deployed services. And this isn't even a new idea either. Service-oriented has been around since the 80s, but it's funny how it will keep cropping back up as a good architecture strategy. And I remember until I really read up on it, I kind of thought I'd invented service-oriented, and then I was all like, oh, nope. So with the command pattern, it's kind of a similar thing. It will make the modules more complex and the repository less complex. It is debatable whether or not the command pattern actually makes modules more complex. It does make them bigger, but it makes them more focused. And then likewise, decreasing the complexity in the repository, it becomes straightforward just because you have all of your user actions segmented into their own modules. So maybe you've seen this graph before. This is project size versus complexity for strongly typed and weakly typed languages. So you'll see for smaller projects, weakly typed is definitely simpler to work with. And then as the project grows, the complexity airplane decides to take off, and then suddenly last minute it decides it wants to go to space. So you do not want your code going to space. And that's actually why we consider our strategy to be so effective. It allows us to to make our services as big as we possibly can before they become too unwieldy to work with. So yeah, that is the Codedge dash line of awesomeness. But this isn't necessarily a magic bullet for every case. Everything always has exceptions. So I have a flowchart here. It's the handy-dandy Codedge architecture decision process. Just 3 questions. So let's start at the top left. Is it a corporate marketing website? Now, this is one of the most frequent questions I seem to get asked, mostly by big companies that don't really know what software is, but they know that they need websites. So generally for those types of jobs, we immediately reach to Phoenix. Now you might be thinking, oh, why don't you just use a static site generator? To which I say, that's cool until you need a contact form, or maybe a little tiny blog system, or hey, I just want to like display some banners from time to time. Suddenly the complexity jumps up. It's not purely just static visualization. There is a little bit of logic to it, which we find that Phoenix and LiveView are just a perfect fit for that. But let's say it's not a corporate marketing website. So the next question is it a big scope? Well, if no, then you reach back to Phoenix again in the monorepo style. This is a lot of times things like very, very simple CRUD applications that, you know, if a user just wants to be able to log in and like, I don't know, manage pictures of cats or something, and that's really all it does, then yeah, Phoenix would be the perfect fit. But let's say it is a big scope. Well, the final question here is, do you hate your future self? Now, if you thought 2020 was a pretty good year, then go ahead and stick with the monorepo style. I imagine I probably just irked some people in the room a little bit, but okay, you can build good systems in the monorepo style, but it's very, very difficult. This is the main reason we don't want code that's ever a dumpster fire. By separating out into your separate repositories, if one of them is a dumpster fire, not all of them are a dumpster fire. But if you keep it in the same repository, yeah, there could be a dumpster fire there. So that's really not what we want. So let's go ahead and change gears a little bit. Let's talk about continuous integration. Now, it is October, and I wanted to be a little spooky. Yeah, so we have the photo on the left here. Those are two servers sitting on a filing cabinet. One says dev and one says prod. Yeah, no, it's not what you're thinking. They were not client production services running on our filing cabinet. This was actually where we used to host our self-hosted GitLab installation. My co-founder is the most frugal person on earth, so we didn't even pay for those servers. He got them for free. I kept saying, hey, let's move it to the cloud, and he was like, nah. Eventually, I got my way, but for the first little while at Codedge, yeah, it ran on that box. And so GitLab works really, really well for all of our processes. It's been so woven into the company because we've been using it since the start. We've built all of these really amazing Elixir pipelines. We use it for private hex packages. Basically, our code is great because of the things we've been able to automate with GitLab as we do this. And for some reason, it seems like every big company that we've worked with that uses GitLab, their pipelines are just bad. I don't know if it's maybe apathy or they just don't know what you can do with Elixir pipelines, but generally it's just like test, build, deploy. And it's like, that's cool, but what if we did something better? So this is a screenshot of the Codedge marketing website. We've got 11 stages on it, and I will break it down. Some are boring, some are interesting. We'll run through all of them, but you'll see kind of an overall picture of what we do. So we have here the test and lint stage. This one is pretty straightforward. Key takeaways are we use EX coveralls, we use mixed format, check formatted, and we use Credo. All of those tools are great. If you're not currently using them, that's like step 0 to having good applications. So I recommend that, that you start there first. Let's talk about Dialyzer for a second. So Dialyzer, I consider it the gentleman's type checker. It is effectively, you want to be classy in your development process. Dialyzer used to be very terrible to work with. It is a lot nicer now. The error messages are actually legible now. It tells you a lot, and it's really effective to use. Type specs are hopefully something that you should already be putting in your code. Once you get hooked on type specs, it becomes one of those things that whenever you read documentation, you always read the type specs first before you actually read the description of the function, weirdly enough. I feel like my whole world just kind of revolves around type specs. But for the people who don't necessarily like Dialyzer, I think a big part of the problem is that they don't use it from day 0 of their project. Dialyzer, if you add it in after the fact, that becomes very, very difficult to work with. But if you start it from day 0, you catch errors early and often, and everything works well. So this is a neat feature of GitLab. It can actually host per project static documentation. Not a lot of people know about this, but this is actually the main reason why we don't use private HexPM packages. We basically host everything with GitLab, and we have all of our documentation in one place. So the stage itself is actually pretty straightforward. All you need to do is have exdoc in your dependencies, you run mixed docs, and then you move that documentation into a public directory within your CI stage, and then GitLab will handle the rest. It'll just deploy it for you, and then suddenly you have hosted docs that are, most importantly, gated behind your authentication. So you're not just publicly hosting your private documentation. But it makes it very, very easy for developers to be able to reference things. You can put badges in your README. Everything's nice. So there's an important piece of this. This isn't a CI stage. This is more like you need to understand this to understand the rest of the CI stages. If there is one thing that gives it away, that it's a Codedge project, that we built it, it is the version file. It seems like our whole process kind of revolves around this version file. And so it's as simple as it's a little text file in all caps, version. You put the semantic version in there, and then we reference that from everywhere. So you can see the snippet on the right. We read it in, we trim it, we set it as an app module variable, and then it gets compiled into the project. Everything works great. But then likewise, having that version file in the project root, you can also reference it from CI, and suddenly your shell scripts and everything become very, very easy to work with. There is, for a lot of people, I call it the O.1.0 club, and so you know who you are, that if you initialize a new Elixir project and then you never touch the version again, I feel sorry for you, because semantic versioning is great. Mix, it works so well with it. It fits so well with service-oriented architecture. And most importantly, it gives your whole team a language with which to express changes in your code. So if you're just tagging your Docker images with a commit SHA and just throwing them out on the cluster, you don't really know. I mean, yeah, you know what was in the change, but you don't necessarily know the implications of the change. And that's why semantic versioning forces you to at least say something of the sort of, oh yeah, this is just a patch, like don't worry about it. Or hey, this is a major version change, we're gonna break something. So going off of the version file, we have the release stage, which is kind of the first step once you've merged onto master and you're preparing for this code to go out in the wild. So GitLab has a really cool releases section, and it's very easy to configure CI to be able to tag your commit with whatever version it is. Unfortunately, there's kind of some weirdness. You have to prepare the tag before you actually tag it. So that's why we have it broken up into two stages here. But going back to the version file, we only trigger this if the version file changes. So if it detects a change, it'll run the stage, it'll tag the commit. Most importantly, if you downgrade the version and it runs it again, the git tag will fail. If you want to just merge to master and not deploy anything, well, you just don't change the version file. Seemingly, what is just a text file actually dictates a lot of flows and ways you can approach the repository. So for building your images, this is pretty straightforward. We like to build a Docker image on every feature branch. I don't know how many of y'all do this. We find it works really well for our developers that a lot of times, yes, you are editing Docker files, you're tweaking things with deployments. It is good to just see like, okay, yeah, we're not going to screw anything up here when we go to build an image. But with the way that GitLab artifacts work, it makes it very easy to build an image in one stage and then publish it to a Docker registry in another stage. And so that's exactly what we do. So before the commit is tagged in the release stage, there will be a Docker image built, and then the image publish is only triggered on changes to the version file after the release, from which it just fetches the artifact and then does a Docker push, and it's got the semantic version in there. which once again is catted from the version file, and everything works great. We have the final CI stage in here. This is kind of just a little add-on. So Codedge loves Sentry. We have been using Sentry for years and years now. They have a really awesome GitLab integration. We actually use self-hosted Sentry. We might be migrating to the SaaS platform at some point, but basically Sentry does one thing well, and that is error tracking. It works so well with GitLab, and it works even better with release tracking. So you can tell Sentry, hey, there is a new semantic version of this code. It will lump in all of the code changes from the prior commits, and then once that version is out running in the wild, if there's any errors with it, it will detect that, hey, there was a regression probably caused by this version, and then it will actually email the authors of those commits to be like, hey, go fix your code. It's really, really cool. So what about deployments? So let's talk about Kubernetes for a second. Now, this was really interesting. There was kind of an argument that came up within the Elixir community a couple years ago. People seemed very resistant to Kubernetes because they kept thinking like, hey, isn't this basically the beam? Why do we need to run things on Kube? And honestly, that's a fair assessment because they are pretty much exactly the same. But you have to think about the problem that Kubernetes was actually trying to solve. So Kube is written in Go. Go doesn't have any sort of supervision. It doesn't have any sort of load balancing or CPU throttling. So it only logically makes sense that something like Kubernetes would exist. And so in light of this knowledge, I took the liberty of redesigning the Kubernetes logo here. Been calling it GoBeam. It's, yeah, I'm a graphic designer, by the way, part-time at night. But Kubernetes itself, where a lot of people that might consider it competition with the Beam, I actually see it as an opportunity here. So you've heard this question over and over again, who supervises the supervisors? Well, we have an answer for it. Kubernetes supervises the supervisors. No matter how great the Beam is, it still can't reschedule itself on another cluster. You need some sort of external thing that can move the entire running piece of software somewhere else. And so this actually fits in really well with my idea within the fractal nature of software. I call it fractal monitoring. So thinking about the Beam in general in an Elixir project, you have super, super responsive restarts, schedulings, error handling, all of the good stuff. Whereas at the Kubernetes level, all you really have are your readiness and liveness probes to dictate what's going on. So it makes sense then for Elixir to be able to monitor itself. It's infinitely more responsive, but then you also have the fallback of the Kubernetes side to be able to handle truly catastrophic failures. This combination, Go can never beat it. Go will only ever have Kubernetes. And so that's why I think this is so amazing that we have an opportunity here because Go and Elixir have been neck and neck on so many things for such a long time, but we won this battle. So why don't we truly utilize the opportunity that we're given and deploy everything to Kubernetes? So we have here getting it on the cluster. Now, a lot of people, there's really good integrations with GitLab to just deploy directly to Kubernetes. That's really cool. If you type things into the Google, you can figure out how to do that. That's not something I'm going to talk about here. There's another tool that we actually really, really like that we use for all of our internally hosted Codedge services, and it's called Keel. So Keel runs as a daemon set on your Kubernetes cluster. Very, very lightweight. All it does is poll your Docker registries, and then you can set semantic versioned deployment rules. So that might be things like, hey, on patch bumps, go ahead and auto-deploy. On minor bumps, require 1 approval. On major bumps, require 3 approvals. Really, really easy, really, really powerful, works great with the service-oriented. And there is finally, so for Keel, it has really fantastic webhook support. I have here a little diagram of our deployment webhook triggers. So Keel, it has a lot of different integrations for a lot of services. It also emits just generic webhooks, which we actually wrote a tiny little Elixir service that will take in those webhooks, and then based on the appropriate project that's configured, it will notify Sentry that there was a new deployment, and that is different from releases. Releases are just for the code. Deployments are, hey, this is actually running in the wild now. So it'll forward it on, and it will post at Sentry, hey, there was a new version. Likewise, it will fork the flow and also notify Discord just so we all get pinged about it. Which, by the way, if you've never used Discord before, I highly recommend it. It is the official Codedge chat. It's written in Elixir, has really great Elixir syntax highlighting. We are big Elixir fan, or big Discord fans. So in review here, so you've seen our architectural styles with service-oriented and domain-driven design. You've seen how we've implemented the command pattern in here. You've seen our CI process that we consider the true foundation of how we build really great software. And you've seen how we do things on Kubernetes. So the great thing about opinions is that there's so many of them, and clearly we're right, but yeah. But this is one of those things that if these ideas speak to you, well, Codedge is hiring. We look for developers who want to try to push the boundaries of design and become the best developers they can possibly be. If, on the other hand, you thought everything I said was dumb, well, you can send me a very angry email, and I'll argue with you on the internet because I love doing that. But regardless of whichever way you feel about it, I hope ultimately you learned something. And with that, thank you.